Hello again. This is the second video for section 13.6. Now, I told you in the first video we're going to be talking about two different types of questions. One is where there's an infinite number of answers, and it's really just using the unit circle, but there's a lot of thought that goes into each one of those, so hence the length of that first video. Sorry. The second one, there's some explaining as to why there's restrictions. Okay, we're dealing with inverse trig functions. And we want to evaluate this, but with a second type of question, when you see that capital letter, where that cursor, unfortunately, there we go. When you see that capital letter in the inverse trig function, whether it's inverse sine, inverse cosine, or inverse tangent, there's restrictions to it, okay? So that's what we're talking about. Now, I've got to explain where these restrictions come from and why they're there. I'll try to do that as quick as possible, but it needs to be explained a little bit so you have an understanding of what it's about. Once you understand where those are coming from, the questions are simple. All right, so as it says up here, the graphs of the sine, cosine, tangent function, they all fail the horizontal line test. Now, automatically your memory should be saying, hey, horizontal line test, that's the one that tells me if the inverse is a function. Okay, you look at the graph of a sine function or a cosine function, it's failing miserably. The horizontal line test. Same thing with the tangent function that looks like this. That fails the horizontal line test all over the place. So that means the inverse is not a function, which means if we plug something into that inverse function, we wouldn't get an answer. We can't have that. I mean, there's going to be answers. So what we have to do is restrict the domain in just a way that gives us a function that's going, the inverse is going to be a function, okay? So, where those restrictions come from? All right, I gotta go back here. Here we go. Change a couple of things. I was messing around with this. Here we go. Okay, this red graph that you see here, that is the sine function. Just a basic sine function. When we talk about the inverse functions, we take our graph, reflect it over the line y equals x. That's this black function that you see here. That's the inverse. And you can tell, it fails the vertical line test. That inverse, it's not a function, okay? It's failing miserably. So we need to restrict the domain of our original function, this graph. Now, we got to restrict it in such a way that it's going to make it the inverse a function. We got to have all of our values. Now, what I mean by that is our sine function, it has a minimum at -1. Okay, the axes are kind of switched around, but and it has a maximum at +1. So we need to have everything in between those y values of -1 and +1. Got to have them all. We want our function to be a continuous function. All right. We don't want to be skipping over certain parts to go to another set of values. And we want to be as close to 0 as possible. We really want to include those positive angles, you know, like between 0 and 90 degrees. Those are the ones that give us the right triangle definitions. And so we got to have those things. And so what we're going to do is restrict our original cosine function to be between this minimum point and this maximum point. All right, it's a continuous function. We have all of our values between -1 and 1. We have our positive angles from 0 to pi/2 or 90 degrees. All right, so that gives us everything that we really need. Now, let me get rid of this ink here that I drew on there. And drop the eraser. Here we go. All right, so let me get rid of the original function. And now what we're going to have is this graph that you see here, this tiny little curve. That's our inverse sine function, okay? It's a function. It passes the vertical line test. We have our values, our angles from -pi/2, which is a -90 degrees, all the way up to here, which is a +90 degrees. Remember, when you have an inverse, you switch your x's and y's. We're going between -1 and +1, okay? So, on the unit circle, that's what we're looking at down at the circle down here in the bottom. Here's -90 degrees. We have everything around to positive 90 degrees. So when we talk about this arc sine, we're dealing between negative 90 degrees and positive 90 degrees. So quadrants 4 and 1, that's where we're going to get our answers from, okay? Between negative 90 and positive 90. That's for the inverse sine function. Okay, let me, again, clear the ink. Why is this not working? Oh, there we go. I hope. Oh, this board drives me nuts. There we go. Clear the ink. Okay. Let's go to the inverse cosine function. It's the exact same thought process. All right. If we look at the original cosine function, we got to have all the values between positive 1 and negative 1. We want to have those positive angles between 0 and 90 degrees. We want it to be a continuous function. So we're looking at just this part of the graph, which goes from 0 degrees to pi. All right, that's what we want to restrict our cosine function so that the inverse becomes a function, which gives us this graph here. All right, so we are between 0 and pi, which is 180 degrees. Okay, this graph that we're looking at, this is the graph of the arc cosine, or that inverse cosine function. On the unit circle, we're looking at quadrants 1, from 0 degrees all the way around to pi, so quadrants 1 and 2. That's where we're going to get our answers for the inverse cosine. And just real quickly, the tangent, when we deal with the tangent function, our restrictions are the exact same as the sine, arc sine, inverse sine, between negative 90 degrees and a positive 90 degrees, all for the same reasons. So let's go back to our notes. Okay. When we're dealing with these problems where we have that capital sine, inverse sine with that capital S of a ratio, square root, no, I'm writing all these crazy numbers here, square root 2 over 2, we are going to get one answer. Because it's the inverse sine, here's our restrictions. Okay, if it was the inverse cosine, these are our restrictions. For the tangent, these are our restrictions. Those are the only places you're going to get your answer from. Depending on the trig function you deal with, that's where your answers are coming from. Or answer, because there's only one. So let's do some examples. Okay, so to evaluate this function, our answer is going to be one angle. It's a theta value, it's an angle. And again, just like in the first video, when dealing with the inverse trig functions, I like to rewrite it. It just helps me process and think about what I need to find. So I'm looking for an angle. When I take the sine of it, it gets me negative 1/2. So let me go back to this unit circle here. I want to copy this. Come on. There we go. Paste. Okay. I'm looking for an angle measurement that when I take the sine of it, it gives me negative 1/2. Because it's an inverse sine that we are solving, we are only dealing in quadrants 4 and 1. So on the unit circle, sine is the y-coordinate, so I'm looking for an angle that has a y-coordinate of negative 1/2, and that's right here. Okay. You'll see that on your unit circle. This is 330 degrees, but again, we're dealing between negative 90 and positive 90. So that's a negative 30 degree angle. So that means our answer is negative 30 degrees. Okay? That's our answer for that problem, negative 30 degrees. That's the thought process for all of these things. So let me clear this up so we can do another example. Try to move the board here so we can see our numbers better. That works right there. Okay, sorry about all that. So now, inverse cosine of square root 3 over 2. Because it's the inverse cosine, we are dealing from 0 degrees to 180 degrees. Cosine is the x-coordinate, so we are looking for an x-coordinate that is square root 3 over 2 right here at this angle measurement, which is 30 degrees. There's our answer. If we were dealing with radians, pi over 6. All right. For the next example, the inverse tangent of negative square root 3 over 2. Once again, another example of, I hope you've been figuring out some of your tangent values and putting it onto your unit circle. To get a negative square root 3 over 2, okay, because it's the inverse tangent, we are dealing with negative 90 degrees around to a positive 90 degrees. So we are not dealing with anything over here. We're only looking in quadrants 1 and 4. Okay, the tangent is tangent of an angle. That is your y-coordinate over your x-coordinate. So to get to a negative square root 3 over 2, we got to be looking in quadrant 4. In quadrant 1, all those values are positive. Okay. In quadrant 4, one's positive, one negative. That's where we're getting our negative square root 3 from. So the tangent value, again, if you don't have your trig functions, what we're looking at, negative square root 3 over 2, if you divide that by 1/2, that's giving you the negative square root 3. So y over x. I am looking for the angle that has an x-coordinate of 1/2 and the y-coordinate to be negative square root 3 over 2. That's this point right here, which is this angle. To get to here, that's a negative 60 degrees. Okay, so we're still using our unit circle, but we're only getting one answer, and it's based off of our restrictions on these inverse trig functions. The last set of problems is a combination of some of these things. Really, it's just composite functions, all right? So, this is part A. This is some bad writing here. There's an error there. Cosine of the inverse tangent of square root 3 over 3. All right, so it's a composite function. Order of operations says you do the inside function first. That's that one. So I'm looking for an angle measurement that when I take the tangent of it gives me square root 3 over 3. Let me see if I can get that picture back up here. Come on, there we go. Paste, there we go, good. Okay, inverse tangent, once again, restrictions between negative 90 and positive 90. So we're not looking over here at all for the inverse tangent. To get square root 3 over 3, what we're really going to get is 1 over square root 3, which comes from 1/2 divided by square root 3 over 2. Tangent's y over x, so I'm looking for the x-coordinate to be square root 3 over 2 and the y-coordinate to be 1/2 as this one. We're looking at this angle measurement, which is 30 degrees. So what that means here is we're going to take the cosine of 30 degrees. That inverse tangent of square root 3 over 3 is 30 degrees. Now we take the cosine of that. Cosine of 30 degrees on the unit circle at 30 degrees. Cosine's the x-coordinate. Square root 3 over 2 is our answer. So we're doing the same things, but it's just a composite function. All right. That is it for section 6. That is it for chapter 13. Again, please email me if you have questions on any of this stuff. I'll be more than happy to answer it. The notes, the answers, PDF version is all going to be on my website. Use those, use the textbook, ask questions. That's it. Bye.